Hey guys, Alfred here. I love mathematics. I've always loved numbers. I've always loved patterns, finding patterns, doing maths ever since my childhood, and I still do. But now I'm faced with a difficult problem to find my most favorite number above. And this is difficult because there are thousands of numbers above a million, way above a million, that I love and which are dear to my heart. And there are certain numbers that I love which are there in the playlist, in this hashtag MegaFavNumber playlist. And after all this, I still don't have the most favorite number. It keeps changing all the time. But I'll talk about one such number that has been close to my heart. And that number is 10 billion, 30 million, 211,011, or 10030211011. It's fun to say this way. So you already know what's going on with this number. It's a lot of zeros, ones, twos, and threes. We know we're going to talk about a particular base, but for now, let's stick with base 10 and find its properties. So number one, it's a prime number. It obviously had to be a prime. It surely had to be a prime. Nothing wrong with composites. You know, you're fun and interesting in your own ways. You have way too many friends. But primes have only one true friend, and that's one. That's one of the many reasons that justify my love of primes more than composites, but that's for another video. So it obviously had to be a prime. Now let's go back to the base concept that we found before. It's written in base 4 because of the zeros, ones, twos, and threes. So let's consider that number as a base 4 number and convert that to decimal. You get 1,000,000, 100,000, and 101, or 1100101. Again, it's fun to say this way. Now, if you notice, it's a prime number, and it is also written in binary because of the zeros and ones. So let's consider that number a binary number and convert that to decimal. You get 101, that's 101. And 101 is a prime number. It is also binary because of the ones and zeros, so let's take that number. Consider that as a binary number. Convert that to decimal. You get 5, and 5 is a prime number. So a prime and a prime and a prime and a prime. And that's what I call PRIME-CEPTION. Of course, this should have a mathematical term behind it, but I didn't go deep into researching it. I just found it out from tinkering with the number. So I found this number 9 months ago when I was trying to make an amateur message, like the Arecibo message. Now, I'm not a certified cryptographer, but I was an amateur obsessed with encryption for some time. So I decided to write this message, and then I was hunting for primes that I could do easily by hand but were not too small because I wanted the picture to be pretty sharp. And I found this number with a lot of ones, zeros, twos, and threes. So I thought, hey, this will be fun to do by hand. And I did by hand because I'm insane. The other prime that I used to multiply with, that is again another wonderful number. It deserves its own video, but I'm not going to think about it now. And that's how I found this number. Then 2-3 months after that, I began finding certain properties in this number. And 2 months ago, that is on June 26th, 27th, I found out this PRIME-CEPTION thing. So I thought this would be a fun thing to share. And if you want to share your favorite number above a million and you're invested in doing so, you could think about uploading your video. And I'm not a maths YouTuber, I'm just an avid viewer of such wonderful YouTube maths channels. So if you would like to join this before September 2nd, you can post a video about your favorite number above a million using the hashtag MegaFavNumbers. It's there on the screen. And with this, if you have been, thanks for watching.